Hello, and welcome to PCI's Tech TV. In this episode, I will be demonstrating how to input and set up digital frame aerial imagery into the 3D FeatureXtract software so that we can accurately extract 3D features. Before we can begin, we need to input the data into the system and set up the geometric model. The geometric model is essential for accurately triangulating the XYZ coordinates. Therefore, this Tech TV episode will focus on a small set of important steps that will help you to begin using 3D FeatureXtract with your own digital air photos. Let's get started. In today's episode, we're going to be working with digital frame stereo imagery captured from an Intergraph DMC sensor. The imagery is accompanied by a camera calibration report, which is used to set important camera parameters, and an exterior orientation file that was generated from GPS and INU information via aero triangulation software. So let's get started. As you can see, we have 18 different images that we're going to ingest into the FeatureXtract software. So the first thing is, let's open up 3D FeatureXtract. Now that the software is opened, I'm just going to rearrange this window so everyone can see. We're going to click on the Files tab here. This brings us to what's known as the Backstage. The Backstage provides a very simple and easy method for setting up and organizing your geospatial data for a given project. So the first thing we need to do is load our data into the software. So I'm going to bring up the Load Data panel, and I'm going to select all of my DMC imagery and click Open. The software will process the data and ingest it as images, and it should all be organized under the Images section here. Once we have our imagery loaded into the 3D FeatureXtract software, we can then click on this very nice feature called Batch Aerial Workflow. Batch Aerial Workflow provides a wizard-style graphical interface for setting up our interior parameters and exterior orientation information so that we can set up our geometric models. So with DMC imagery, we only really require the focal length and the chip size. To get that, I'm going to refer to the calibration report that is provided with, or should be provided by your data provider. Every calibration report is different for different types of sensors, but this is what it looks like for the DMC camera. So to set the focal length, I'm going to refer to this table here, and I see the virtual focal length is 0.12 meters. We require it in millimeters, so I'm going to set it to 120. I can then click on the radio button for the digital chip size, and I'm going to set up my width and height of the chip. So once again, the calibration report provides the virtual sensor size and the virtual pixel size in micrometers. So we can use this to calculate our chip size. I'm going to simply bring up the calculator, and I'm going to look at the first value, which is the length, as 13,824 times 12. And this gives me my chip size in micrometers. I can then simply input that into the height field here, and I'm going to provide it in millimeters once again, so 165.888. And I'm going to do the same thing with the width. So 7,680 multiplied by 12, and that gives me my chip size in the width. So 92.160. So now I have set up my interior orientation information. The next thing I'm required to do is to set up my exterior orientation. Now, with this batch function, all we have to do is to specify the spatial reference system that our coordinates in the exterior orientation file are based upon, and in this case, it's a local projection. That is very common with digital frame aerial sensors and surveying. So it's important for you to understand how to do this, as this may be your case. Obviously, we do support some of the more basic like UTM and state plane and long lat, but in case you're using a local projection or one that is not defined here, we have the custom option. This is where you can specify a string that basically provides all of the geospatial information or spatial reference system information based upon a well-known text markup language, which is an OGC standard. There is a lot of information provided online about this OGC standard. To save time, I'm just simply going to copy and paste the string that I've predefined and click OK. So then after that, we need to basically define our file format. So as I mentioned, the file format of this particular exterior orientation file is the image ID XYZ omega phi kappa, or omega phi kappa. We need to specify the input angular units, which in this case, the omega phi kappa are based off of degree. And then we're going to point to the exterior orientation file. And it loads here, so we have a chance to inspect our values. I'll simply click Next, and once I have this, I can quickly see that my imagery is properly already associated to the correct ID. And if it's not associated, we can select from the list and correct any mistakes that the software might have made. We then click Next, and now our geometric model is added to the software and the imagery, and we can begin collecting our features. To do this, we're going to click on the Add Vector Layer button here. This creates a new unnamed feature set where it's just going to store our 3D vectors. We can then click on the Home tab, Layer Manager, and our vector layer that we created, our empty vector layer, will show up. You can click on this checkbox to display it, and then this radio button to make it the active layer, the layer that we will be collecting or extracting our features from. I'm then going to find an image down here in our slider, right click on the image, and I'm going to send the image to our left viewer. And then I will send its neighboring image to the right viewer. I'm going to click on Camera Lock, which will lock these in place, so when I zoom in one, it will zoom in the other, as well as panning. And I can go to our Feature Extraction tab in order to begin collecting a feature of a building. So for example, if I wish to simply collect this roof here, and if I just want to get the outline, I can begin digitizing by holding down the Control key, click on a corner, and then just drag and click. And then once I get my final vertex, I can use the right click key, or right click button on my mouse to close it. It's then, as you can see, it's going to put that same polygon onto our other viewer. I can simply then drag this polygon, or zoom out a little bit, drag this polygon. As you can see, I'm locked in the epipolar direction, so it only lets me drag it along the epipolar axis, and I can, as you can see, it lines up very nicely with my feature. This gives me confidence that my geometric model is correctly set up. That's all for today. Thank you once again for joining us for another episode of PCI's Tech TV. Have a great day.